So, how many molecules of NH3? Can you see my screen?
Yeah.
Okay, I just want to make sure. How many molecules of NH3 will be produced from 821 grams of H2? Okay, so we have a bunch of different stuff going on here. First off, what are we looking for?
We're looking for how many molecules of NH3.
We're looking for molecules of NH3. So I'm going to put X molecules underneath NH3. What information did they give us?
821 grams of H2 gas.
Okay, so I'm going to put 821 grams underneath H2. Do you see how they gave us information about H2, but asked us information about NH3? They're giving us information about one compound and asking us about another. Do you see that?
Yeah.
Okay, so in order to do that, to go from one compound to another, you're going to use a horizontal line. In order to go from one compound to another, do you know what you have to use?
The coefficients.
That's right, so I'm going to put coefficients on the top of this line. Just as a reminder, that's what I need to use. Now, in order to use the coefficients, do you know what unit we have to get it into?
Moles.
Moles. So I'm going to put moles on one side and moles on the other, because the coefficient goes with moles. All right, so let's take a look at what they're giving us and what they're asking for. They gave us grams. Is that moles?
No.
No, so we have to get to moles. How do we go from grams to moles?
Put the grams over 1.
Well, what do we have to find out? What kind of number do we need? Grams goes with what?
Grams go with moles, so they're not. Oh, hydrogen.
The molar mass. So whenever you see grams, remember you need to be thinking periodic table. As soon as you say periodic table, you need to figure out the molar mass. So we're talking about H2. That 3 in front does not play in. Okay? We only use that 3 for the coefficients. That's not now. So how many hydrogens do we have?
2.
And then what's the mass of hydrogen?
1.01.
Okay, so that brings us to 2.02 grams per mole. Okay, so now we can go from grams to moles of hydrogen. Then we can go from moles to moles using the coefficients. What's the question asking us about?
How many molecules?
Molecules. We need to go from moles to molecules. What number goes with molecules?
So 6.02 times 10 to the 23rd.
There you go. All right. So now we have our plan. The whole point of doing this graph type thing is to just get us a plan of what we have to do. So you notice that we're using the molar mass to get to moles, coefficients to get from moles to moles, and then Avogadro's number to get from moles to molecules. You follow the plan?
Yes.
All right. All right. So now that we're going to start, when we start doing the conversion itself, what do?
We put are we starting with 821?
That's our starting point.
Okay, and then we put that over 1.
821 grams of H2 over 1. Okay, we have grams of H2 on the top. What do I put on the bottom? The next one.
Grams of H2.
All right. To go from the grams to moles, right here, we're going to use the molar mass. Okay? So what are we going to put on the bottom next to grams?
Is it a 1?
It's times 2, though, because there's H2.
Oh, well, 2.02.
2.02. What'll be on the top? Grams per
grams, 1 mole.
1 mole of H2. This is grams per mole. Now we have moles of H2 on the top. We went from the grams to the moles. So when I'm looking at this, we went from here down to here. So now we're in the lower left-hand corner, and we want to get to the next compound. You see what I'm saying?
Yeah.
Okay. So in order to do that, what are we going to use? What's the word there?
Which word?
The word right here on top of that line.
Oh, coefficients.
Coefficient. So what number goes with H2? What's the coefficient of H2? What?
Is it of H? Oh, 3.
3 moles of H2. They're asking us about NH3. What's the coefficient of NH3?
2.
So 2 moles in H3 is going to go on top. So we have now changed compounds. Now that we're in the NH3, which is what we were looking for, we need to get from moles to molecules using our last conversion factor. Okay, molecules go with Avogadro's number. We have moles of NH3 on the top. What am I going to put on the bottom, the next one?
Moles of NH3.
What number goes with moles?
1.
1 mole NH3. What am I going to put on the top?
The 6.02 times 10 to the 23rd.
Yep, I ran out of room. But yes. All right. We have it all out. Now all we have to do is put it into our calculator. Yay. You got your calculator handy?
Yes.
Awesome. So make sure that we're using that EE button at the end. So you might have, if you're using your iPhone as a calculator, you're going to have to turn it to the side.
Okay.
So 821 divided by 2.02 because it's on the bottom, times 2 because it's on the top, divided by 3 because the 3 is on the bottom, and then times 6.02 EE or EXP 23. What did you get?
1.631 E26
That E means times 10 to the 26.
times 10 to the 26.
How does that feel?
Good.
Good. Is that a little better? Want to try another one?
Yeah.
All right. In the formation of CO2 from CO and oxygen, how many liters of CO2? So what are they looking for?
The liters of CO2.
So we're going to put XL underneath the CO2 for how many liters are produced when the reaction of 8 moles of O2. So where am I going to put that?
Under the O2.
Very good. With excess carbon monoxide. That excess just means we don't have to worry about it. It's extra information. All right, so are we changing compounds here?
Yes.
Yes, as soon as we're changing compounds, we have to draw that horizontal line. What word gets put above that horizontal line?
Coefficient.
Coefficients. All right, what's on either side of that arrow? What unit does it have to be in? Right, very good. All right, so our starting point was 8 moles. Do we need to convert that?
No.
No, because it's already in moles. Our ending unit is in liters. Do we need to convert that?
Yes.
What number goes with liters? Oh, what's molar volume?
Is it the 22.4 liters equals 1 mole?
Yay!
I wrote it down.
You're so smart. Okay. So, do we have our plan written out now? Do we know exactly what we're going to do?
Yes.
All right. So, what's our starting number?
Oh, wait. The 8.
8 is correct. 8 moles of O2 goes over 1. We have moles of O2 on the top. What am I going to put on the bottom, the next one?
Moles of O2.
Moles of O2. Now I'm going to go up and I'm going to look at my plan. I am right here. I'm trying to get to right here. What do I use to do that?
The coefficient.
The coefficient. So what's the coefficient of O2?
1.
All right, and I'm trying to get to the CO2. So what's the coefficient of CO2?
2.
Very good. All right, so I'm done with the coefficients now. And I can cross out the moles of O2. Now I need to go from moles to liters, because that's what the question was asking for, right?
Mm-hmm.
If I'm looking at my plan, I can see that I already have written out that I need 22.4. So I have moles of CO2 on the top. What do I put on the bottom?
Moles of CO2.
What number always goes with CO2?
1.
1 is correct. The only time it's not is during that horizontal line. Okay, so what's going to go on top to make it into liters?
22.4.
Very good. You're so smart. Okay. Moles of CO2 cancel out. So from here is what we're looking for on the top of the last line.
Yes.
So that means we just throw it into the calculator, go from left to right. We're going to put in 8. And then because 2 is on the top, we're going to multiply it by 2. And then because 22.4 is on the top, we're going to multiply by 22.4. If those numbers were on the bottom, we would be dividing. So 8 times 2 times 22.4. What did you get?
358.4.
Yay! That's not so bad, is it?
No.
No? Do you want to try one on your own, or do you want to do another one together?
I could probably try it on my own.
Okay, I'm going to pause the recording. We're going to resume. And, all right, so how many liters of sodium sulfate? Where am I going to put my X?
Underneath the the 2. Is it the 2 in the OH?
Well, I'm asking, what's the question asking about? It says how many liters of sodium sulfate? Which one's sodium sulfate?
Oh wait, the Na2SO4.
Very good. So X liters will be formed if you start with 2 moles of sodium hydroxide. What do I do with that information?
You put that. Are you asking what goes underneath it, or like
Yeah,
what to do
where
with
would
it?
I put that underneath of? Which one's sodium hydroxide?
The NaOH.
I'm going to put 2 moles of NaOH here. All right, so do I need a horizontal line?
Yes.
Why?
Because you're going from, I forgot what it's called.
You're changing compounds, right?
Yeah.
Okay, so what's on the top of that line?
Coefficient.
Coefficients. What's on either side of that arrow? What unit?
Moles.
Moles and moles. All right, are we starting off with moles?
Yes.
So I don't have to convert that. Am I ending in moles?
No.
So I do have to convert that. How do I get to liters?
The 22.4.
Okay. All right, so do we have everything we need to solve the problem?
Yes.
All right, so what's the first line? What's the first fraction?
2 moles of NaOH over 1.
Okay, I have moles of NaOH on the top. What do I put on the bottom? The next one.
Moles of NaOH.
All right, if I'm looking at my plan, I am right here. I'm trying to get over to Na2SO4. What do I use to do that?
The coefficient.
The coefficient. What's the coefficient of NaOH?
2.
Okay. We're trying to get to the Na2SO4. What's the coefficient of that?
1.
So 1 mole of Na2SO4. Now that we've used our coefficients, we're not going to use those again. The moles of NaOH are canceled out. We're trying to get to liters. We have moles of Na2SO4 on the top. What do I put on the bottom of the next one?
Moles of Na2SO4.
And what number always goes with moles?
1.
What am I going to put on the top of that to get us to liters?
22.4.
All right, so the moles cancel out, and we're left over with liters. Is that what we're looking for?
Yes.
Yes, so that means we're going to calculate 2 divided by 2, because it's on the bottom here. We're going to divide, times 22.4 because it's on the top. What did you get?
44.8.
You forgot to divide by 2. Try the calculation again. 2 divided by 2 times 22.4.
Oh, I got it.
You got it this time?
Yeah.
Awesome. Do we want to keep going, or do you think you're okay?
I think I'm fine now.
Yay! Okay, let me turn this off.